Government makes progress towards a independent transmission system operator. Eskom finds a workaround to get power from Karpowerships, and Koeberg shows us why baseload power is outdated. My name is Shanley. Welcome to my YouTube channel. Okay, so there's an article from Business Live or Business Day, and in the article they're reporting that Cabinet has adopted a draft electricity amendment bill for a TSO or transmission system operator. And what this would do is it's basically the initial steps or some steps that would lead towards establishing a transmission system operator. Okay, so to understand, where this sort of fits in, at the moment, South Africa's energy system consists of a few parts. Okay, so we have the electricity generators, and these consist of many power plants, coal-fired power plants, pump storage power plants, several other types of power plants. It also consists of the transmission network, and the transmission network is what gets the power from the power plants all the way to the end users. At the moment, Eskom owns most of the generation plants, and it also owns the main transmission network. Now, there are other players as well. They are independent power producers, and independent power producers also own some of these plants. But in order for the independent power producers to get their power from their generation plant to their end users, they have to make use of Eskom's transmission network. Okay, and so the way this works is, now Eskom has its own generation plants, and it has a transmission. But Eskom is such a big company that the transmission business and the generation business operate somewhat independently. And when a generation business or when a generation plant has enough power or has power that they would like to feed onto the grid, they feed that power through the transmission network. But there is a commercial transaction between generation business and transmission business, and it's almost like they are operating as two separate entities. So there is this transaction that takes place. It's effectively the transmission business bills the generation business for the use of Eskom's network. And this bill, although it's internal to Eskom, it still operates. It's still a commercial transaction between the business entities. But Eskom has had, since about 2008, Eskom has had a method or framework of allowing independent power producers to be able to also feed power into the grid, and this is known as wheeling. And basically, Eskom transmission treats independent power producers the same way that it treats Eskom generation plants. So in the same way that when an Eskom generation plant wants to feed power into the grid, they charge the plant for a network fee for using the transmission grid. Eskom treats independent power producers, their power stations, their plants, the same way. And there's this commercial transaction between Eskom transmission and this independent power producer. Okay, but the difference lies in the fact that Eskom generation does not need to think about customers. Eskom generation only needs to focus on producing electricity and making sure that the plant is up and running. The power goes to transmission, it's distributed to the end users, and Eskom retail, the commercial side of Eskom, takes care of the transaction between the customers and Eskom. And at the moment, Eskom has a monopoly on the electricity market, and so most people that get electricity get it through Eskom. Whether they pay a municipality who in turn pays Eskom, or if they're a direct Eskom customer and they pay Eskom directly. At the end of the day, most people who have electricity in the country are getting their electricity directly from Eskom. And so a generation plant doesn't have to think about who's going to receive this power and who's going to eventually pay for this power. They don't have to worry about that. An independent power producer, on the other hand, they do need to think about that. They need to think about who's going to be the end user of this power, and they need to make sure that their money is collected. And the end user of that power and the payment for that power might come through one of a few methods. One method being through a wheeling agreement. that they have with a off-taker. It could be a commercial user, an industrial user. It could be some sort of plant. The other option is also they could have a power purchase agreement from that they've obtained through a government independent power producer procurement process. So that's how they would have to get paid for the power that they produce. Okay, but they'd have to think about that. Now, the benefits of a transmission system operator, operationally, nothing would really change. So again, at the moment, if you're an independent power producer and you would like to feed energy onto the grid and you have an off-taker, you can do that, no problem. You can apply for grid access through Eskom, and you can pay the same network fee that all other Eskom generation plants are paying. So operationally, there's no real difference. A transmission system operator would offer no operational difference. It's still the same thing. We're feeding power onto the grid, we're getting charged a network fee, and it gets to end users. The benefit, however, that a TSO or transmission system operator provides is that it removes potential discrimination. Okay, so at the moment, Eskom is the entity that approves or rejects grid access. And there's then a potential for discrimination. Eskom can decide, this business wants to produce power. They want to put it onto the grid. But we feel that, these customers that they're supplying, we would like to rather serve them. And then they might reject that application. So Eskom has this, there's a potential for discrimination. There's a potential for Eskom to reject an independent power producer from feeding energy into the grid for their own benefit. Okay, so there's a bit of a conflict of interest there, and so an independent TSO will force Eskom to basically compete with independent power producers. So now Eskom is treated like a power producer, just like every other independent power producer is treated like a power producer, and everybody has an equal opportunity to be able to feed power into the grid. And Eskom would then need to compete with this. Eskom would need to make sure that the power that they're producing is well priced. It's reliable. It's at a certain times. It's operate according to certain operating regimes, and yeah. So basically, it'll force Eskom to compete with independent power producers, and this will obviously result in improved services and better use of our resources. And with several of Eskom's power plants being set to be decommissioned over the years to come, Eskom will naturally lose market share in the electricity market. And so it just makes sense again to have an independent TSO, especially when we get to the point where most of the generation is not coming from Eskom, but is coming from multiple independent power producers. And so again, so the move by cabinet to adopt this electricity amendment bill for establishing this TSO is definitely a step in the right direction. And perhaps there may be some hiccups along the way. It definitely is a step in the right direction. It might still take some time for us to get there, but it's definitely something that we need, especially given the fact that Eskom will at some point lose the significant market share. But we also need to understand that the progress of IPPs is not hindered by this TSO. If it takes a long time for a TSO to be established, independent power producers will not be hindered. They will still continue to organize, to arrange wheeling agreements with end customers, and there's still this opportunity or this framework for Eskom to access the network through Eskom's wheeling program. And so the only thing that might stop that, though, is if Eskom decides to hammer down on or to just reject wheeling or grid access for wheeling. So there's that danger. But again, operationally, everything is already in place for independent power producers to be able to feed energy into the grid. Okay, another article from Business Live reports on the possibility of Eskom purchasing power produced by Karpowerships through Mozambique. You might recall that Karpowerships are these large sea vessels, these large ships that have basically gas to power plants built on them, and they manufactured, I believe it's in Turkey or somewhere up north. They come down to where they're needed. In our case, there were basically three ports of entry, or three ports where these Karpowerships were going to be stationed. They were going to be connected to the electricity grid, and they were basically going to feed power into the electricity grid while the power plant remains on the ship and produces the power and just sends the power into the electricity grid. It's a very interesting concept. The ship stays there. It comes to the port. It's fully functional, and it also makes refueling very easy. You have a fuel vessel that comes down to where the ship is, where the Karpowership is, and refueling is very simple. It's just a connection from the fueling ship to the power plant ship. And so there were these Karpowerships that were part of one of government's independent power producers procurement programs, and this company Karpowership was awarded to be able to have three of these ships at 3 points along our coast. But the reason it didn't go through, the reason why procurement of these had to basically stop or had to be cancelled, the deal had to be cancelled, was because there were several environmental concerns, especially relating to the fact that this is basically power that is being produced, and the ship is in the sea. The effects it might have on marine life, on the sea. So there were these environmental concerns, and in addition to the environmental concerns, there were also some corruption concerns. There were just things that looked a little bit off. Why was there these ships, this company from Turkey that seems to have gotten such a big chunk of the allocation in this independent power producers procurement program? And so for these reasons, we didn't go through as a country. We didn't go through with procuring these Karpowerships. But now there's this potential for Eskom to still be procuring power from these Karpowerships, but instead of South Africa procuring these Karpowerships, Mozambique is procuring them, for their own needs. Mozambique has decided that they need some power. There's some instability in the region with regards to power, so they're going to go ahead and they're going to procure some of these ships. They're going to feed it into their own grid, and they're going to be selling power to neighboring countries. At the moment, we already buy some power from Mozambique, so there's already that commercial relationship set up. But the deal now is that Eskom would buy electricity from Mozambique, and the electricity would come from these Karpowerships. And so essentially what we're doing is, instead of us dealing with the issues of these Karpowerships, we're now basically outsourcing those issues to Mozambique, and we're just getting the power. In fact, another issue that there was with these Karpowerships was the fact that South Africa would have to be locked into something like a 20-year agreement at a very high cost, and it just didn't seem feasible. So there's also one of the things that just kind of seemed off. Why was this company given such a large allocation, while at the same time the commercial agreement or the commercial terms just seemed so unattractive? So there's all these downsides, and with Mozambique now procuring these Karpowerships and South Africa through Eskom just procuring the power, there's a potential to benefit from the power that we would have gotten from these Karpowerships without engaging or without experiencing the downsides of the commercial deal and the environmental issues. So we're not experiencing environmental issues. We're basically outsourcing the environmental issues to Mozambique, which also is a bit questionable. But anyway, aside from the downsides from the commercial side and the environmental side, I'd like to just spend a bit of time thinking about the merits of Karpowerships. So I do believe that there are some positive aspects to Karpowerships. One of them being the fact that the technology that's being used is gas to power technology, which inherently is a very flexible technology and allows for quick ramping up and ramping down of power generation. The other thing is also, depending on the technology that is used, they generally make use of synchronous generation. And again, what this means is that synchronous generation is the type of generation that assists with maintaining the grid frequency. If you do not have enough synchronous generation technology or generation on the power system, you introduce some grid instability to the power system. And so the Karpowerships provided these two, have these two advantages. They are flexible technology, being gas to power, and they also are a synchronous generation, which provides for grid stability. And why is this good? Well, in South Africa, we have a lot of potential for wind and solar. And we have the potential in South Africa for wind and solar basically to become the workhorses of our country. At the moment, the workhorse of our power system is coal, and it's baseload power. But there is an opportunity, given the large amount of wind and solar power, the large amount of wind and solar resource that we have in the country, and given the price decrease or the decrease in prices of the technology over the years, wind power and solar power have become incredibly cheap, and South Africa is very well placed for these technologies or these resources to become the workhorses of the country, replacing fossil fuels, replacing coal. However, if South Africa's power system is going to become mainly based on wind and solar, then we need to understand that these are variable sources of generation, and as a result of that, we need to have flexible generation to back up the variability of these technologies. And so, gas to power is a brilliant technology for backing up renewables that are variable. And also, renewables introduces grid instability. Renewables, wind and solar, do not produce synchronous power, and as a result, there's a possibility for a lot of grid instability being introduced into our power system. And again, gas to power with synchronous generation is really good for us because it puts that stability back into our power system. And so, Karpowerships would have been a really good. I think it would have been a really good technology to introduce into South Africa's power system for these two things. It would complement renewables in the sense that it would provide the backup that we need to renewables, and would also provide the grid stability that we need. But unfortunately, the commercial issues and the environmental issues have muddied the waters. No pun intended there. But this is what has happened. And again, I think it would have been really good technology had it not been for these, for the commercial issues, the potential for corruption, and what looks like corruption, and of course that long 20-year commitment. And I think there's an opportunity for us to learn from this, and the opportunity there is that we don't need to outsource this kind of. We don't need to get this technology from overseas. We don't need to import this technology. We are capable of doing gas to power inland. And if we do gas to power inland, we avoid these environmental issues that would have been experienced with ships in the water. And additionally, if it's done locally, if it's done inland, so we reduce the environmental issues, and we can also have better contractual terms. We can look at contractual terms that best fit our needs in the country and best fit what it is that we would like to do with our power system. But I'd also like to mention that it's been a few years since this procurement process took place. This independent power producers program, a procurement process took place where Karpowership was awarded this allocation. And over this time, hydrogen technology has become a little bit more cost competitive. And so now we're at a point where, back then we might have benefited a lot from doing gas to power. But now we're at a point where gas to power is competing with hydrogen, and it actually makes more sense in some cases to go with hydrogen for flexibility rather than to go with gas to power. And so, this deal with Mozambique, with Eskom procuring the power from Mozambique, might be a good thing for South Africa because, in a sense, we still get the benefits of the flexibility and possibly synchronous generation, while at the same time avoiding all the issues that came about or that we would have experienced had we gone directly with Karpowerships. Okay, and then lastly, I want to speak about Koeberg. So MoneyWeb, there was an article by MoneyWeb, and it spoke about Koeberg Unit 1. Koeberg's 1 unit is currently on planned maintenance, and it was supposed to come back online during the winter, but unfortunately that's been now pushed out for various reasons. It's been pushed out to September, and so power that would have come back online during the winter time is now being pushed out to the springtime. Koeberg unit 1 is over 900 megawatts in capacity, and I think that this, the fact that it's on maintenance, it's a great opportunity, a great learning opportunity for us to see that baseload power is outdated, and that baseload power, this mindset of baseload power, has basically reached its expiry date. So I'm going to spend some time just talking through this. Think about a graph. Think about a chart, and in the y-axis you have power, right? You have power in megawatts. And in the x-axis, you have hour of the day, okay? And baseload power basically is a large rectangular chunk of power. And its height, the height on this graph of the baseload power is the capacity. So for example, Koeberg Unit 1, we have on this graph, in the y-axis we have power, x-axis we have hour of the day. In the y-axis, the height of this graph is 920, 930 megawatts, and the width of the graph basically stretches across the graph over the 24 hours of the day when the unit is online. Okay, so that's what baseload power looks like. It's a large chunk of power that stretches across a graph, a large rectangular chunk of power that stretches across a graph. The part of the problem, as we build on this idea that baseload power is outdated, part of the problem is that demand is not rectangular. The way the power system works is that there is a minimum in the morning, or overnight there's a minimum. The way the demand curve works is that overnight there's a minimum. It ramps up in the morning to a peak, and then kind of settles to sort of a midday minimum, and then ramps up again towards the afternoon, or late afternoon, late evening, or early evening rather, and then it settles again to the overnight minimum. And baseload power is basically only effective up to that overnight minimum. Above that overnight minimum, you need to use different technologies. You need to use alternative operating regimes. And the technology that we use for that is what we call mid-merit and peaking power stations. And these are plants, in the case of mid-merit, these are plants that can be switched off and switched on from day to day. And in the case of peaking, these are plants that can ramp up very quickly, within minutes, to be able to match the differences between supply and demand. And these kind of power stations are what we call flexible generation. So they are flexible in the sense that they can be turned on and off from day to day, and they can be ramped up and down minute by minute based on the demand of the country, and they can operate like this without any negative effect to the hardware. In the case of baseload power, you can't switch them on and off from day to day, it's very bad for the for the hardware. It's very bad for the power station. It reduces the life of the power station. But mid-merit and peaking, these can be switched on and off, and these can be ramped up and down with not much problem. The second part of the problem is that when routine maintenance is required, in the case of baseload power, when routine maintenance is required, you lose a large chunk of power. Okay, there's a large chunk of power that is not available when these plants go into routine maintenance. And as we see in the case of Koeberg, maintenance on nuclear plant is only supposed to take about 90 days. With this plant, it's taking something like 200 to 300 days. Can't remember the exact number, but it's taking a really long time. And the point is that in a baseload power station, when routine maintenance is required, you have a large chunk of power that is not available for as long as that power is, or that unit is in maintenance. And the question then becomes, how do we fill that gap when this baseload plant is not available? You can't fill it with another baseload plant, because that would mean that you have this excess capacity that's just sitting there waiting for another plant to go down. And it becomes really expensive for this plant just to sit idling while it's waiting for this plant to go down. And then when this plant goes down, maybe you operate it, the plant comes back up again. Now you switch off this baseload plant, and now it's just sitting there waiting again for this plant to go into maintenance. It's very, very expensive. And so when we think about filling this gap, we then have a choice. Either we have to fill that gap with expensive power, or we have to sit with load shedding, which is what we are going through right now. We need to understand, or we can't deny the fact, that solar and wind have become incredibly cheap. Solar and wind per kilowatt hour have become much cheaper than coal and nuclear, and it's something like 40% cheaper. Per kilowatt hour, solar and wind are about 40% cheaper than coal and nuclear. And if South Africa does not capitalize on the cheap power of solar and wind, and moves towards making solar and wind the workhorses of our power system, we may lose a financial opportunity, a very big, a very strong financial opportunity, and a competitive advantage in the world to have cheap green products. But if South Africa is going to make wind and solar the workhorses of our power system, solar and wind needs to be complemented by flexible generation and storage. Okay, and this can be in the form of gas to power, like we saw with these Karpowerships. It could be in the form of hydrogen, or it can be in the form of batteries. And we need these kind of technologies to be able to complement the renewables system. Renewables is variable. We need flexible technology to be able to complement it. We need the flexible generation to be there when in times of low wind and low sun, and also to be able to account for the mismatches between supply and demand. Unfortunately, coal and nuclear are not compatible. Coal and nuclear cannot ramp up and down to fill the supply gap between the mismatches between supply and demand between renewables and the energy and the country's demand. So renewables, a renewable system would consist of hundreds of small plants spread across the country, as opposed to baseload plants where we have a few mega plants, a handful of mega plants in maybe 2 or 3 provinces in the country. And just by that metric alone, renewables is more reliable. If you have a system where there's a handful of generating plants that you rely on, versus hundreds of generating plants that you rely on, spread across the country, operated by multiple different companies, versus a small number of of big plants operated by one company that doesn't seem to be doing very well at operating, this system of the renewable system inherently is a lot more reliable. Also, when it comes to routine maintenance, in the case of baseload power, you have large chunks of power that are not available during those times of routine maintenance, and they're not available for a large or significant period of time. In the renewable system, we have, instead of large chunks of power not being available, we have intermittent losses, small intermittent losses of power that can easily be filled, or that can cheaply be filled with flexible generation. Cheaply and easily be filled with flexible generation and storage. And so this is what we are this is what we are faced with. We either continue with baseload, where we lose the financial advantage, the financial benefits of cheap renewables. In addition, we are faced with either having to fill up demand and supply gaps during routine maintenance with expensive power. We have to either choose between that or load shedding. Or we can have a alternative system where we have hundreds of plants all over the country, much more reliable system, much cheaper electricity, complemented by flexible generation. And when there's routine maintenance, it's small plants, small losses of power here and there. When there's low sun, when there's low wind, the difference, the deficit is easily and cheaply filled by flexible technology. And so if we continue with our mindset of baseload power, we're always going to we'll always have to be choosing between load shedding and expensive power. And so we need to embrace this new way of doing things. We need to embrace a new way of doing things, of having renewables and combining that with flexible generation, and we can reap the rewards of that. If we embrace this new way of doing things, we can reap the rewards. And in South Africa, the rewards are greater than almost every other place in the world. I'm glad you enjoyed that video. Please feel free to look at other videos on my channel, and also make sure you go to my website, shanleylutchman.co.za, to find other articles on business and energy.